Good afternoon, ladies and gentlemen. Welcome to my presentation. My name is Pia Sold-Rindler. I work at the company Wood K+, and my today's talk is about wood species-dependent performance of pMDI bonding strength. So, the development of bonding strength of a thermosetting adhesive generally takes place during the curing process under the influence of temperature, pressure, and time. The curing process itself strongly depends on two different properties, the properties of the binder and the properties of the wood substrate. Focusing on the binder, some properties such as the reactivity of the system, the molar ratio, the amount of hardener and the type of hardener, the solid content, additives, or also the degree of condensation are important. For the properties of the wood substrate, thickness of the composite, the wood species, some extractives, and also the moisture content are important. These influencing factors are very well known for amino resins and phenolic resins, but not fully investigated for pMDI. So we examined how the use of different wood species, including different wood moisture contents, affect the bonding performance of pMDI. For the testing setup, we used an automated bonding evaluation system, also known as ABES. This instrument can be used to test the tensile shear strength independence of pressing time and temperature to investigate the bonding strength development of an adhesive. As wood species, we have chosen pine, spruce, birch, and beech, each conditioned at 3 different moisture contents, so 8, 12, and 16%. These veneer samples were then pressed for 75 seconds, 5 and 10 minutes using pMDI as binder, and immediately after pressing, the tensile shear strength of the sample was tested. When we have a look on the next slide, we can see the first results. These figures show on the one hand a strong influence of moisture content on the bonding strength. So the higher the wood moisture content, the faster the bonding strength of pMDI develops. However, this is a very well-known effect and can be explained by a high reactivity of isocyanate groups to all compounds containing hydroxy groups or also water. Furthermore, we can see significant influence of wood species, whereby pine shows an outstanding good bonding strength. Having a look on the right figure, we can see that pine with 16% moisture content is already fully cured after only 1 minute of press time. Based on this result, we wanted to examine why pine wood performs that good. Therefore, we extracted some pine veneers with an acetone water mixture in a sock sled. After reconditioning the extracted veneers, the samples were tested in the same way as the previous samples. Interestingly, we could see a slower bonding strength development in comparison to the untreated pine. As a third test, we used the residual pine extractives and sprayed them on spruce, beech, and birch veneers. Surprisingly, the tensile shear strength of pMDI pressed for 5 minutes increased significantly for spruce and beech, and slightly also for birch. This leads to the conclusion that pine extractives can be used as a primer to accelerate the curing of pMDI. To summarize my results, we could see a very strong effect of wood moisture content on the bonding performance of pMDI, as well as a significant influence of the use of wood species. Furthermore, pine wood performed the best, where the pine extractive seems to act as an accelerator. We furthermore analyzed the residual extractives, which consist to 82% of abiotic acids. As final result, it can be concluded that these pine extractives could be perfectly used as primer to speed up the curing of pMDI. I'm now at the end of my presentation. I hope you got a quite good insight of my work, and thank you for your attention.